very warm welcome to everyone. So, welcome to the lecture series of the course Marketing Research and Analysis. In the last lecture we were discussing about the importance of data purification, why researchers need to be very careful. This is one of the areas which researchers tend to ignore in the haste for doing a publishing a paper or completing a research work, but then they land up into more difficult trouble, and then they have to regress back and maybe do the entire research again. So, that consumes in the totality more time. Had they been slightly more careful and handled the data better in the beginning itself. So, data purification becomes a very important subject of discussion for any research course. In the last class we were talking about the three things. For example, one was the case of missing data, right. So, missing data, then we talked about outliers. We had just begun, we have not gone deep into outliers, and then the third case was of normality, right, in which we had started about the first case. This is what we were discussing, and we will maybe carry forward with this only today in this lecture. So, missing data, as I said, there is what will you do when there is missing data with you in your data set. For example, this is a hypothetical example. You see there are certain variables V1, V2, V3, V4, V5. Now, each variable has got, there are certain missing data. For example, here there is a missing data, here there is a missing data, in this case here and here missing data are there. So, if you can see, variable wise there is also you can calculate the missing data, and case wise you can calculate the missing data. For example, from in case, if you see, the first case has got no missing data, but others there are some missing data. For example, 2 missing data here, there is 3 missing data here, 1. So, it is distributed, right. In case of variable, you can also you see that there are some missing data here in each variable, and maybe this variable has got the highest missing data, and in this case this case had the highest missing data, correct. So, the question is what will you do when you have such kind of missing data? Will you ignore? Is it possible to ignore? Then you can ignore, no issues, if it is not creating much of a trouble to you, if it is too less and it is not that important. But suppose you cannot ignore, then what? Then you have to maybe replace the missing data with something a more realistic, a more correct data, right. Okay, fine. So, let us see how do we approach this problem of handling the missing data. I am sure every researcher will face the problem of missing data, but they tend to general approach, I will tell you honestly speaking, is I have seen people filling it up with some numbers, just some numbers, right, because they realize that the computer does not understand and it takes any number given to it, but then they do not realize that they are doing more harm to themselves instead of doing good. Why I am saying they are doing more harm to themselves? Because once you have filled in a data set, you have put in some data, how it works? It works through a large permutation combination across the variables, right. So, once you have done it, the entire data, the mechanism changes of how it functions, it changes. Now, suppose you even yourself might have forgotten which data you have replaced or you have changed. Now, when you do that, it could be possible that the entire analysis is coming off track, it is coming something weird and wrong, right, and then you are in a loss because you do not remember even what you have done, right. So, why you should do that? When there is a scientific approach to handle your missing data, then why should you be doing all these things? Okay. So, let us see. So, this is the rule of thumb, deletions based on missing data. The question is, if you have less missing data, you may delete it, right, or let us say there is you find that there are few variables which have large number of missing data, you can delete them, but the question is here you have to use your own logic, right. How much deletion is possible? If I delete one variable out of maybe 20, maybe it is okay still, but if there are only 5 variables I am deleting 1, maybe I am deleting 20%, right. So, that you have to decide. Variables with as little as 15% missing data are candidates for deletion, right. See, books would always tell you very nicely that you should be very clear and you should delete it, but the point is always deletion does not serve our purpose, right, because sometimes we may we may land up in a lesser number of variables or cases, right. Higher levels of missing data up to 20 to 30% can often be remedied. So, it says if it is less than 15%, you may delete it. If it is more than 20 to 30%, you may remedy. So, my question is, then why not even treat the 15%? Why should you delete it the first thing, right? So, if it is 15, if you can have a remedy for 20 to 30%, then why not handle it even at 15%? Okay. Be sure the overall decrease in missing data is large enough to justify deleting an individual variable case, right. So, it is there is sufficient data is there with you, that means cases with missing data for dependent variables typically are deleted to avoid any artificial increase in relationships with independent variables. So, if a dependent variable, right, has lot of missing data, in such a condition they need to be carefully handled. While deleting a variable, ensure that alternative variables hopefully highly correlated, means they are more or less behaving the same, trying to explain the same thing, highly correlated, are available to represent the intent of the original variable. That means there is another variable which can take care of the variable that you might be possibly deleting. Always consider performing the analysis both with and without the deleted cases or variables to identify any marked differences. So, there is a statistical technique we will see how to deal with such problem. Diagnose the randomness of the missing data. Is it what is the pattern of the missing data? Is it a random, what is the randomness? Is it highly random, completely at random, or is it just at random, right? So, having determined the extent which we have done is substantial enough to warrant action. The next is to find the degree of randomness present in the missing data. Now, why is that? Why is it important? What will happen if I do not consider I have sufficiently large number of data. So, what happens if I do not study the randomness, right? It is possible that you might be missing a very important observation, that why are people only missing, there is missing data in a particular data set at a particular variable, or why a particular kind of respondent of a particular place maybe are having missing data. So, those are very important observations for a researcher, and they need to be carefully handled and observed and understood also, right. So, the randomness of the missing data sometimes gives you extra information. Okay. So, two things: missing at random, missing completely at random. Missing at random means the propensity for a data point to be missing is not related to the missing data, but it is related to some of the observed data. Now, let us see this. Now, whether or not someone answered question number 3, let us say you have certain questions, I have just given an example, question number 3 out of 20 questions 2003 on your survey has nothing to do with the missing values, but it has to do with the values of some other variable, right. In the last lecture I had explained you about blood pressure and age relation, right, age and blood pressure. So, when I said is there any relationship, yes, it was found that young people were generally not reporting their blood pressure values. Okay. So, this is the case. Okay. So, a better name would actually be missing conditionally. So, the condition, there is a condition, right, if it is young they are not reporting. So, conditionally at random, because the missingness is conditional on another variable. That means the missing value of one variable is dependent because of another variable. That is why this case is called a missing at random case, and it is more complicated in comparison to the other one which is missing completely at random. What it says, the propensity for a data point to be missing is completely random, there is no pattern, it is just people have not given a reply, right. Why they have not given, there is no why for it. Yes, the difference is in the missing at random case there is maybe a why they have not given, there is a reason, but here there is no reason, there is no relationship between whether a data point is missing and any values in the data set missing or observed. So, this is very easy to handle. Okay. So, testing, how do you test the level of randomness? As previously noted, the researcher must ascertain whether the missing data occurs in a completely random manner. When the data set is small, the researcher may be able to visually see, suppose it is a small data set, you may visually see the the patterns and perform some calculations. However, as sample size increases, the number of variable increases, the need for tests also goes on increasing. Some statistical programs and techniques specifically designed for missing value, for example, in SPSS, which I will conduct and show you, right, in just in this lecture. So, when you have a large data set, suppose you have a data set of 10,000 people, Can you and there are 100 variables, can you visually do anything with it? Impossible. So, in such a condition you can use some techniques available in the softwares and take care of the missing data. So, the first approach assesses the missing data process for a single variable y by forming two groups. Now, what it is done, you see, to check whether the missing data is actually having an impact or not, what is done, the data is divided into two groups. One group where some missing data is available, the other group there is no missing data available, right. And then a simple t-test, a statistical t-test is performed to determine whether significant differences exist between the two groups. So, you understood? So, group 1 let us say and group 2, right. So, group 1 let us say has got missing values, it has got no missing values, right, no missing values. Now, when I compare the data set, these two data set, suppose significant differences exist, right, it indicates the possibility of a non-random missing data process, right. So, what it says, if significant differences exist, it is a case of a non-random missing data approach. The second is called the overall test of randomness, right, that determines whether the missing data can be classified as MCR. How? You see, this test analyzes the pattern of missing data on all variables and compares it with the pattern expected for a random missing data. If no significant differences are found, in this case significant differences were found, here no significant differences were found, then the missing data can be classified as yes. Did you understand? I hope you have understood what happens. Make two groups and compare these two groups. If significant difference exists between group 1 and group 2, then it is a case of a missing at random data, right. If there is no significant difference, then it is just a randomness and is such a worrisome factor. So, here we need not be so much worried. Okay. Now, once you have done with these things, then we come to the fourth and the most important part. What is this? Here we would try to impute or replace the missing value with some logically right value. Okay. The researcher must select the approach used for accommodating missing data in the analysis. This decision is based primarily on whether the missing data are missing at random or missing completely at random. But either case, the researcher has several options for imputation, right. So, let us see, let us not get into this random and non-random, rather let us see how we can replace the data, because some of you might be very young to research. So, I am not trying to make it more complicated. Let us understand, you have understood the meaning, that is very important, you should understand what is it, if somebody asks you should be able to answer. But then how do I impute, how do I correct my data? Let us go to that. Imputation is the process of estimating the missing value based on values based on some other variables and cases. Let us see, either you can calculate or there are some other methods also. But remember one thing, this is a caution, imputation can be sometimes very seductive and dangerous. Why? It is seductive because you are getting a full complete data set, there is no missing data. So, you are very happy, right. Why it is dangerous? Because you did not understand the reason for the missing data. Maybe you did not understand why there was a missing data. Was it a logical reason, there was a logical reason for having missing data and you ignored it and you just filled up the missing data. So, now that thing is still lying, why he had not, the respondent did not fill up the data, that thing you have just ignored without any logical reason and you have tried to just go across to your analysis. So, now it is very dangerous. So, you do not know why it had happened, but you have filled it up. So, you are forcing the data now. Okay. The second thing is metric versus non-metric data. See, naturally when the data is metric, that means let us say interval scale or a ratio scale, a continuous scale for that. So, when the data is measured in a metric scale, it is a metric data, then okay, fine, you can go for a missing data approach. What if the data is for example non-metric, for example gender, male and female. Now, suppose there is the person has not filled up whether it is a male or female. Should you try to impute the data? No, you should not be doing it. I would advise never ever go for imputation of non-metric data, because it makes no logical sense, right. Had the data been a metric data, for example in a scale of 1 to 5, let us say how much is the score the respondent is giving. Now, suppose so people have given different scores, somebody has given 2, somebody has given 4, somebody has given 3, somebody has given 5, somebody has again given 4, it is fantastic. Somebody has not given, let us say here he has not given, we can determine, right, by using some substitution method. But if it is a non-metric data, it is 1 0 or it is just a nominal scale, it is only a representation, what is the meaning of trying to fill it up, right. It is a very big mistake people do, so be very careful with it. Imputation of missing data process, use only the valid data or replace values for the missing data, right. Now there are different methods, let us see each one of them. Imputation using only valid data. Some researchers may question whether using only valid data is actually a form of imputation, because no data values that are actually replaced, that means you have just deleted maybe, right, you have not replaced anything. So the intent of the approach is to represent the entire sample with those observations which have a valid data. Okay, fine, no issues, good, but suppose in the process you have deleted a large number of cases, then their opinion or their observation, their perception you have ignored, right. So by doing this, maybe a large size of the population you have missed or a large sample you have missed. So you do not understand what these people were even thinking, what was their feeling, right. So that is dangerous. So deleting too much can also be a dangerous case. Now coming to some of the methods. Complete case approach, the best. The simplest and the most direct approach for dealing with missing data is to include only those observations with complete data, also known as the complete case. This method is also known as list-wise method in SPSS, okay, forget it. So this is a complete, so anyway a complete case is always good, but the question again I am saying is complete case, if you delete too much then also it is not very advisable. The second imputation method uses only valid data that does not actually replace the missing data, but instead imputes the distribution characteristics. Now what are the distribution characteristics? Through the mean, the standard deviation or the correlation. So it uses all the available data and tries to use these parameters to fill up the value, the missing data, right. Now coming to imputation by using replacement values. So use a known value or calculate replacement value, either you use some known value or you calculate the value. Now let us see. Now when you do this using the known replacement value, the observation it uses two techniques. First is called the hot and cold deck imputation, the other is called a case substitution method. I will explain each one. Now what is this hot and cold deck imputation? In the hot deck imputation method, the value comes from another observation in the sample that is deemed similar. So another observation which is very similar looking, right, each observation with missing data is paired with another case that is similar on a variable specified by the researcher. So any similar looking variable, if it is available, you can use those variables data and fill up this missing data, right. So then the missing data replaced with valid values from the similar observation. This is a hot approach, okay. The cold approach says the replacement is from an external source, not from the existing data set, from an external source, for example prior studies or other samples. So you have seen somebody has done a similar study and there is a data set, you feel it is very similar to mine and you can and there is a pattern, so you can use those data and fill it up. This is a cold deck approach. Here the researcher must be sure that the replacement value is more valid than an internally generated value. So if the researcher is so sure, you are free to do it, no issues. Next comes the case substitution. In this method, entire observations with missing data are replaced by choosing another non-sampled observation. So for example, I can fill up a case, a person, let us say respondent 3 is missing, let us say respondent 3 is missing. Now whatever respondent 3's profile is, I can select similar another person and take data from him, right. So fine, so and the case is substituted, right. A common example is to replace a sample household that cannot be contacted or that has extensive missing data with another household not in the sample, preferably similar to the original observations. Fantastic, clear. Now coming to the calculation of the replacement values. So the second approach includes two methods, one the substitution, mean substitution, and the regression method. Now what is the difference? Let us see. Mean substitution, you replace the missing values for a variable with a mean value, right. So the mean is the most standard method and it is one of the best methods. In the regression method, it is the regression analysis is used to predict the missing values of a variable based on its relationship to other variables in the data set, right. So, this is also possible. You can use the normal equation and find out, right, and you can replace it, or you can use just a mean substitution, the mean, right. What is the rule of thumb? The rule of thumb says under 10% if the missing data is there, any of the imputation methods can be applied when missing data are this low, although the complete case method has been shown to be the least preferred, right. When it is 10 to 20%, the increased presence of missing data makes the all available hot deck substitution method and regression method most preferred for missing completely at random, whereas model based approaches are necessary with the missing at random missing processes. So, I had said about the E and M method, I think in the last lecture, the estimation and the measures of parameter. Over 20% if it is there, so the method is regression and model based methods. So, this is basically for the MAR, right. So, these are some of the what would you do when there are missing data, right. So, this tells you some of the advantages. When it is a complete data, for example, it is simple, right, but the disadvantage is most affected by the non-random processes, right. Best used when the large sample size is large, strong relationship among variables exist, okay, low levels of missing data. So, these are some of the things which you can do, right. Case substitution, for example, is it provides a realistic replacement value. You have replaced the case itself, right, must have, but the problem is disadvantage is that you have to have additional inventory, additional cases, right, which is not there in the original sample. So, the best used when additional cases are available and you are able to identify appropriate replacement cases. Okay. Hot and deck similarly, replacement missing data with actual values from the most similar cases. So, this is a good thing, advantage, but disadvantage is must define suitably similar cases. So, your logic of understanding which is the most similar is also questionable, sometimes it can be wrong also, right. So, establishment replacement values are known, then it is wonderful, then you can easily go for it, right. Mean substitution is easily implemented, very simple. It reduces the variance of the distribution. So, the unexplained component is reduced, right, and when it is used, when the low levels of missing data are there, right, relatively strong relationship among variables exist. Regression is used when employs actual relationships among the variables. Replacement values calculate based on the observations own values on other variables, that means the let us say the number of independent variables available. Unique set of predictors can be used for each variable with missing data. What is the disadvantage? It reinforces the existing relationships, after all you are trying to use the same relationships. So, it reinforces the existing relationships and reduces the generalizability. So, now you cannot generalize. What is generalizability? That means external validity is reduced. Now, you cannot say that this study can be applied everywhere, because the question is by again and again using the same existing relationships and trying to utilize the values. For example, in a bootstrapping method also we do that, which is questionable, right. You should not be doing more and of repeating the exercise again and again, right. Must have sufficient relationship among variables to generate valid predicted values, right. So, these are some of the things. So, where it is used, moderate to high levels of missing data is there. Relation sufficiently established so as not to impact general, this is very important, right. So, these are some of the things that you need to be very careful. Now, let me explain how you should do it. Let me go to an example. So, this is a case which I have brought a data set. Now, this data set, as I have shown you, there are large number of missing data. At the initial stage, let me find out how much of missing data are there. Okay. So, what I am done is I have just taken some missing, so I have taken some of the I can even use these, but since I am not going to correct them, so I am not interested much. So, what I am doing is I am trying to find out how many missing values are there. In V1 to V9, if you see, the highest number of missing values are in V1, right, and the lowest one is in I think 6, V6. So, variable 1 has got a highest number of missing data. The question is, first as a researcher, you should start thinking, why is it that when the questionnaire is the same and is used on the same respondent, why is variable 1 having so many missing data? Is there any specific reason that people are not willing to answer it, or they do not understand it, or something wrong is happening? So, you need to understand this. Okay. So, So, this is something like the from the frequency table what I have done is I have just found out how much of missing data is there. Okay. Now, how do you impute the missing data or replace? Now, let us go several methods are there. Let me explain you the one of the methods here. For example, go to analyze, see if you want to do a multiple imputation you can do it, or if you just want to you can go to transform and see here replace missing values. So, what you can do is you can use this method also, right. There are several options to given you, mean of nearby points, median of nearby points, linear interpolation, linear trend at point, whatever. So, the simplest is series mean I am taking. For example, I can just try it out on this one, right. So, I can use this method and what I will get is I will get a new V1 variable, right. So, I can have it on my table and I can make the study, for example, let us see. So, what it has done now, if you minimize this, now a V1 has been created, can you see. Now, this V1 has got almost no almost there is no missing data, correct. So, you can do this, but this is one by one doing is very cumbersome. So, what I am doing is I will delete it, right. So, kindly delete this if it is possible. Okay. Let it be there, otherwise we are not bothered at the moment. So, what I am doing is I am running the exercise again, right. So, how do you do this? So, go to analyze, there is something you can see multiple imputation, can you see this? So, in this multiple imputation it asks you to handle the missing data. So, what I have done is I am creating a data set, for example. So, I will create, the name is JKN. So, I am saying JKN is my name. So, JKN I am giving it a name, let us say 3. Okay. So, the new data set's name is JKN3. Okay. So, I have done it and I am saying OK. So, once I have done this, so what I can do is now I can go to the JKN3 data set. Okay. So, the JKN3 data set you can see now, if you look at it properly, the missing data, I do not think you can see any missing data out here, right. So, all the missing data has been handled properly. So, V1, V2, V3. Okay. So, now the question is, let me run it again. So, what I am doing is I am taking all the variables 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, you can see it has given you some imputations, correct, the number of imputations. Now, what is the number of imputations? Imputation but nothing but the number of iterations it is allowing you. In generally this software is allowing you for 5, you can increase it further also. So, what it does is takes a 5 imputed values and then after taking these 5 imputed values it takes a pooled value, right. The pooled value is nothing but a representation of the 5 imputed values. Let me show you how to do that. Now, let me show you how to handle the missing data in a data set. This is a case of the data set which I had earlier showed also to you. Now, there are lots of missing data as you can see, correct. So, first you can do one thing, you can just check how much of missing data is there. To do that you go to analyze, missing value analysis. Okay. So, V1, V2, V3, V4, V5, V6, V7, V8, V9, right. Now, you want to see the patterns, right, for example. So, you can check them also, right, or you want to check the descriptives, you can check that also, right. So, what I am doing is I am just trying to see what is the kind of right. So, this is what it says, this is basically the missing data is given to you. In V1 there are this kind of 21, 13, 17, 7, 9, 7, all these are given to you, correct, and the percentage is given to you. So, once you have understood, okay, this is the number of missing data we are having. Now, what do I do here? Now, again go to this and go to the multiple imputation, right, and input the missing values. Now, the variables you have taken, earlier I had taken this variable, so it is already there, right. Now, you have to give a data set a name. So, I have given here JKN1, my name 1, right. So, the method, it takes the automatic method, constraints. So, coming to the output, the imputation model. So, create a name of data set again for iteration history it has to given a new name. So, I have given JKN2. Okay. So, now I have got this multiple imputation table with me, right. So, it is done. Now, let us leave this one and go to the main file, right. So, the main file, a new file has been created. Okay. So, this new file has been created, right, jkn1, if you can see here, right, you can see here jkn1. So, this jkn1 file, now you can see there is a kind of a this is kind of a looking a matrix kind, right. Now, what does it give you? Now, go to analyze. Okay. Suppose I want to compare the means. Okay. So, let us look at how to impute the missing value, right. So, first you can go to analyze, right, and check how much of a missing value is there in your study. So, I have taken all the variables. I have generally ignored the the nominal variables, the nominal scale ones, and I'll check. For example, I can go to here also, tabulated cases sorted by missing value patterns. You can do this, right, display, it will show you something. So, now let us see how much of missing data is there. So, it tells you how much of missing data is there in this is giving you a pattern, right. So, now okay, first we have understood there is some missing data, right. So, this table has already told us. So, again if you want to see this, at least this table is very important for you. So, 21, 13 and the percentage is given. Now, I have done with it. Now, how do I replace the value? So, again I go to this, go to multiple imputation. Now, what I am doing is I have already given a name. So, we can either keep that or you can give a fresh name, whatever it is. So, just I am going okay. Okay. So, by doing this, what I have done, right, let me see what is variable. So, there are two files that has come up. Okay. So, this file is the one which is, if you can see here, the imputation 0 is given. Now, if I change it to 1, right, you can see some yellow colored marks. So, this yellow colored ones, if you go back to 0, let us go back to the original is 0, the 0 is the original data, right. You had these missing values, so kindly remember, for example, the second one, the fourth one, right. So, now what it has done, it has replaced them. So, second, 4, whatever the missing values were there, they have been replaced. So, it has done 5 imputations, as you remember we had given there 5 imputations. So, each imputation the values are given to you. So, there are 5 imputations. So, the question is, we have got 5 kind of data sets now, for example 5 imputed data sets, right, but the one what will you use, which one will you use? So, the question here when it comes, you will use the pooled estimate. Now, what is this, how do you do that? For example, before, suppose I want to analyze this, the means of this study, for example sample means, right. So, what I am doing is I am taking for example, let us say I am taking some of these values, right, and I am just checking the V1, V2, V3, V4 I am taking, and I want to see their means. Okay. Now, if you look at it, if you look at the output table I think here it would be okay. So, you can see here. So, when I taken 5 4 variables, right. So, what it has given me some imputation number, the first imputation, the V1, V2, V3, V4, right, and there are 5 imputations. So, first imputation, after first imputation the variable V1, its mean was 3.684, n was 70, standard deviation was 1.13. Similarly, for V2, V3, V4, but the question is, these are all individual imputations, right. So, what will you take while you write in your research report or something? You will take the one which is the pooled, which is the pooled one. So, the pooled estimate tells you that the mean is 3.702, 2.102, 8.013 and 5.160. So, the pooled estimate is basically representing all these 5 imputed values. So, you can do some other studies also. For example, you want to check, for example, let us say you can do anything. If you can see this, for example, I want to do a bi-weight correlation, right. So, I am taking a bi-weight correlation between, let us say V1 and let us say V2, right. Now, again if you see, if you go back V1, V2, V4 and the pooled. So, you need not write in your research report about the V1, the 1, 2, 3, 4, 5, instead you will write the pooled value, right. So, this is what is the final outcome. So, this is how you impute the values in a scientific manner, and once you do it you can use it for your further analysis. I think I hope this is clear to you, right, and in case you have doubts, you practice and you can ask me these questions whenever you are appearing for your in your doubt clearing sessions or something, you can ask me. You have a way of writing your questions and I will reply to them. Okay? Thank you so much.